In the last video, we described what heat is and what unit we use to express the amount of heat, the quantity of heat, which is energy in simple terms. Here, we would like to just make sure we understand there's a difference between temperature and heat. So, heat is, as we explained, the thermal uh, energy exchange between a system and its surroundings. So, if you have uh, an ice cube placed on the palm of your hand, what happens is that heat is being transferred from your hand to the ice cube. Now, both your hand and the ice cube have different temperatures. So, temperature would tell us how much energy or how much thermal energy is in that sample or in that system. So your hands obviously are a higher temperature than the ice cube. That means heat is going from the ice cube to your hand. So once again, make sure you understand the difference between these two concepts. Now, when it comes to specific heat, which is also an important concept to describe here, specific heat is defined as the amount of heat required to raise the temperature of 1 gram of a one substance 1 degree Celsius. I mean, just think about it, right? If you have two frying pans, one with water, one without water, and you heat both, you know that the one without water will get hotter faster. That's because each substance has a specific amount of heat that can be absorbed. So in this case, the symbol for it is SH. And if we would like to represent this really quick here, so if we have 1 gram of iron and we have 1 gram of water, I know it should be the same size. They don't necessarily have to be the same size, but in this case, should have the same mass. If they're both, let's say, at 20 degrees Celsius, 20, and you would like to increase this by just 1 degree to 21. What we say is that the iron would need about 0.45 joules, less than a joule, whereas water would need 9 times the amount of heat, 4.184 joules. So again, that's what specific heat is. It's the amount of heat required to raise the temperature of 1 gram of a substance 1 degree Celsius. This is exactly what we did. So notice the difference in the amounts, a huge, huge difference. All right, let's talk about the specific heat equation and then move our way to the questions. So this will be a slightly longer video because we have two questions to tackle here. We have SH, which is the specific heat, and its unit is joules per gram Celsius. It could be calories per gram Celsius. Heat is Q. Its unit is joules. M is mass. Its units is grams. And then delta T is the change in temperature, which is T final is the final minus T initial. And that's, of course, in Celsius. So it's a very, very straightforward equation. And you just have to find your values and plug them in. Make sure you have the correct number of sig figs and then move on from there. So let's talk about this question. These questions, as I said, are pretty straightforward because they will tell you exactly what needs to be calculated. So look at this question. It says, what is the specific heat? So right away, we know SH is unknown, it's X. So we set up our equation, SH equals Q over M times delta T. Very well. 57 joules is Q. So we plug that in, 57. 35.6 grams is mass. We said that here. And then this is the temperature difference. You have to calculate, you have to subtract them. So you went from 25 to 37.5. So this is T initial, and that's T final. So what we do is we say, okay, here's delta T, which is T final minus T initial. And that would be 37.5 minus 25.0. And that gives us 12.5 degrees Celsius. So now we take this and we plug it into the equation. Now, before we move on, we ought to be very careful when it comes to sig figs. We need to look at how many sig figs we have here. If you notice, each one, they pretty much have the same number of sig fig. So this one has 3 significant figures, 3 significant figures, and then 3 significant figures. So our answer should have 3 significant figures. So if you have a calculator, it would be really helpful if you attempt this. And when we calculate this value, okay, I'm about to calculate it right now. So 57.0 divided by 35.6 times 12.5, you get, so we can round together, you get 0.128089. Okay, so on and so forth. Now we need 3 sig figs, so that would be 1, 2, 3. So what comes after the 8 is a 0, so we doesn't make any difference. So in this case, we have 0.128 joules per gram Celsius. Now I suggest you, for the next question, that you actually, you can pause, that you actually attempt to do it. It's really just rearranging this equation. So I'll write down the equation for you because now we're looking for heat. So if you just do some mathematical manipulation here, you get Q equals M times SH times delta T. So you can pause the video and think about how you would solve this. And then when you come back, you can look at the answer. So pause the video now and work through this problem. So I hope you went through the problem after pausing the video. If you didn't, well, here it is. But make sure you do enough practice. So it says here how much heat. So right away, we're looking for Q. Q is unknown. So we must be given then the mass. It says 252 grams of iron. So that's the mass. So 252 grams of iron. We raise the temperature from 22 to 98. So this is T initial, this is T final. All right, let's calculate this down here. T final minus T initial, which would be 98 minus 22.0. So that gives us 76 degrees Celsius. And then the specific heat is given right here. This is SH. So times 0.45 joules per gram Celsius times the 76.0 grams, Celsius. And then we multiply all of these together. And when we multiply them, we get, let me write it here, we get 8,618.4, and the unit is joules because let's cancel out some units here. Grams cancel out, Celsius cancels out, so you're left with joules. All right, we need three sig figs because this is not a measured unit, so we have to round to 3 sig figs. This one has 3, that one has 3. So in this case, it would be 8, 6, 1, and then what follows the 1 is an 8, so we have to make it an 8, 6, 2, and then we put a 0 to retain the value, the magnitude, joules. Now, oftentimes this is expressed in kilojoules. So make sure you know how to convert from joules to kilojoules. So if you want to convert this to kilojoules, we did this in the last chapter. You divide by 1,000 because kilo is 1,000, and you end up with 8.62 kilojoules.